Good day everyone, so for today we're going to discuss all about effusion and diffusion. Okay, so always remember that the terms effusion and diffusion are often used interchangeably, but they are not equivalent. Okay, so effusion is the movement of gas particles through a tiny hole. Okay, so this explains why a person can still smell the scent of cologne even if the lid is closed. On the other hand, diffusion is a process by which a gas spreads or mixes with another gas. Okay, so this is when the particles of the cologne start to mix with air as it volatilizes. Diffusion results from concentration gradient. A gas at a location of high concentration naturally tends to move to another location where there is a lower concentration of this gas. Scottish chemist Thomas Graham formulated this law of effusion. This law states that the rate of effusion or diffusion of a gas is inversely proportional to the square root of its molar mass. Graham's law predicts that lighter gas particles will move faster than heavier ones. As the kinetic molecular theory postulates, the average kinetic energy of a gas is proportional to its absolute temperature, and it is expressed in Kelvin. For two particles 1 and 2 at the same temperature, their kinetic energies are equal. Mathematically speaking, it is equal to Ke sub 1 is equal to Ke sub 2, or 1/2 multiplied by m sub 1 v sub 1 raised to 2 is equal to 1/2 m sub 2 multiplied by v sub 2 raised to 2. Okay, so this equation can be simplified and rearranged into v sub 1 over v sub 2 is equal to square root of m2 or m sub 2 over m sub 1, which means that the velocity of each particle is inversely proportional to its mass. Modifying this equation to reflect the speed of the gas particles and their molar masses gives the Graham's law equation. Rate sub 1 over rate sub 2 is equal to square root molar mass sub 2 over molar mass sub 1. Okay, sample problem number 1. A sample of unknown gas took 39 seconds to reach a certain point in an effusion tube. Under the same conditions, a sample of carbon dioxide gas, molar mass is equal to 44.01 gram per mole, took 31 seconds to reach the same spot. Determine the molar mass of the unknown gas. Okay, so next given, so we have times of 1, 31 seconds, times of 2 is 39 seconds, molar mass 1 is equal to 44.01 gram per mole, so that one is the molar mass of carbon dioxide. Next, for the required, we're looking for the molar mass of 2 or the molar mass of the unknown gas. For the equation, we're going to use first, let's write down the general formula. So times of 1 over times of 2 is equal to square root of molar mass of 2 over molar mass of 1. Since both gases travel the same distance, the Graham's law equation can be modified to molar mass of 2 is equal to molar mass of 1 multiplied by times of 2 over times of 1 raised to 2. And then you're just going to substitute the given value. So we have 44.01 gram per mole multiplied by 39 seconds over 31 seconds raised to 2. Cancel out same units, and then the final answer would be 69.66 grams per mole. Okay, next, sample problem number 2. An average carbon dioxide travels at 410 meter per second at 25 degrees Celsius. Find the average rate of chlorine at 25 degrees Celsius. Okay, for the given, we have rate sub 1 is equal to 410 meter per second. Next, molar mass of 1 is equal to 44.0 grams per mole. Molar mass of 2 is equal to 71.0 grams per mole. Next, for the required or the unknown, we're looking for the rate of chlorine gas or rate sub 2. Equation is rate sub 1 over rate sub 2 is equal to square root of molar mass of 2 over molar mass of 1. And then for the equation or the derived formula, we have rate sub 2 is equal to rate sub 1 multiplied by the square root of molar mass sub 1 over molar mass sub 2. Assigning carbon dioxide as gas 1 and chlorine gas as gas 2, here's the solution and the final answer. Rate sub 2 is equal to 410 meter per second multiplied by square root of 44.0 grams per mole divided by 71.0 grams per mole. And then the final answer would be 320 meter per second. Next, sample problem number 3. Find the molar mass of a gas that diffuses about 4.45 times faster than argon gas. Here's a given. Rate sub 1 is equal to 4.45. Rate sub 2 is equal to 1. Molar mass sub 2 is equal to 39.9 gram per mole. The required would be molar mass sub 1 or the molar mass of given number 1. Next, for the equation or the formula we're going to use, so we have rate sub 1 over rate sub 2 is equal to square root of molar mass sub 2 divided by molar mass sub 1. And then the derived formula would be molar mass of 1 is equal to rate sub 2 multiplied by square root molar mass sub 2 divided by rate sub 1. Next, for the solution, so we have molar mass of 1 is equal to rate sub 2 divided by rate sub 1 multiplied by square root molar mass sub 2 is equal to 1 multiplied by square root 39.9 gram per mole raised to 2 divided by 4.45. The final answer would be 2.01 gram per mole. Okay, congratulations STEM 12 students. After several weeks of studying new concepts, we're finally done with the first quarter topics. We hope that you enjoyed learning with us and hope to see you again on the next fun and another exciting lessons and activities. Okay, so again, this is Mom John Arenda, your Gen Chem teacher. Thanks for watching.